Dear viewers, welcome to Source Tutorial. Today we are going to talk about the plastic method of structural analysis. Basically, we have, or let me say generally, we have two methods, which are equilibrium method or static method, and energy method or virtual work or kinematic method. So these are the two methods that are used in solving plastic methods of structural analysis. So whenever you are asked to use any of these methods, you shouldn't be confused. If he asks you to make use of static method is the same as equilibrium method. Energy method, virtual work or kinematic method are all the same. Now I'll go straight to the example we have for today, and you're going to start with the energy method from this example. This example says that use the energy method to find the collapse load P equals to PC and the plastic moment MP for the prompt cantilever loaded as shown. So this is our prompt cantilever, where you have the load alpha P and P, which are loaded on the prompt cantilever, and the prompt cantilever has two supports, one fixed and the other roller, and the distances of the prompt cantilever from A to B is L over 3, B to C L over 3, and C to D is L over 3. Now let's go to the solution and let's know how to get the collapse load and the plastic moment for this prompt cantilever. Now, solution. We have this prompt cantilever as we have seen. Now, the first step, which is step one, to get the degree of indeterminacy of the structure. The degree of indeterminacy ID is equals to 2m plus r minus 2n. So this is a degree, the formula to get the degree of indeterminacy of any structure. But please be very careful, this is for cantilevers and beams. When we are going to talk about frames, it has its own degree of indeterminacy formula you use. Now let's go and get a degree of indeterminacy. ID is equals to, now what is our M? Let's get our M first. M means what? Number of members. What is a number of members? What is a member? In this cantilever, what is our member? Our member is member AD. This is a member. From A to D is one member. So here you have one member. Then R is the number of reactions. Now, how do you get your number of reactions? In getting your number of reactions, what you do first here is you ignore your horizontal reactions. While getting number of reactions. Now let's go to our prompt cantilever. In this prompt cantilever, here is a support, and this type of support is a roller support, and all roller support has one reaction, which is a vertical reaction which acts upward, which is RD. Then in this support B, which is a fixed support, it has three reactions. It has a horizontal reaction which acts upward, which is RA. It has a horizontal reaction, HA, and has what? A moment, MA. So these are the three reactions: the moment, the horizontal reaction, vertical reaction, and the horizontal reaction at this support. Whereas at this support D is only the vertical reaction already that is here. Now excuse me. Now let's count the number of reactions. Please, I said you ignore the horizontal. Let's count 1, 2, and 3. So we have 3 reactions, ignoring the horizontal reaction. Now the next step to do is next thing to do is to get your n. What is my n? N is my number of nodal points. What is a node? Let's go to our structure. This point A here is a node. Point D here is a node. So we have 1 and 2 nodes. So we have 2 nodes. Therefore, we say that our ID is equal to, so substituting this in this, we have 2. What is bracket? What is my m? My m is 1 plus my r is 3 minus 2. My n is what? My n is 2. So if we simplify, we have 2 plus 3 minus 4, which is equals to 1. Therefore ID is equals to 1. Now the next step, find the number of hinges causing collapse. The number of hinges causing collapse will be equals to the degree of indeterminacy plus 1. So what is our ID? Our ID is 1 plus 1. Now this number of hinges causing collapse tells us that this number of hinges is equals to 2. That is to say that two hinges will be formed on our cantilever. That is, in this our cantilever here, in this cantilever, 2 hinges are going to be formed in this cantilever. So